Black holes are among the most fascinating objects in the universe. They captivate our imagination and challenge our understanding of the cosmos. Imagine a place where gravity is so strong that nothing, not even light, can escape. This is the realm of black holes. That is, a black hole, a region in space where the gravitational pull is so intense that it warps the very fabric of the universe. These cosmic entities are regions of space-time where gravity's pull is immense, warping the fabric of the universe. They distort space and time in ways that are hard to imagine. They are invisible to the naked eye, but their influence on their surroundings is undeniable. Stars and other celestial bodies orbit around them, revealing their presence. Black holes challenge our understanding of physics and offer a glimpse into the most extreme environments in the cosmos. They push the boundaries of what we know about the universe. Their existence was predicted by Albert Einstein's theory of general relativity, which describes how gravity affects the fabric of space-time. This theory has been confirmed by numerous observations. They remain some of the most mysterious and intriguing objects in the universe, capturing the imagination of scientists and the public alike. Researchers continue to study them to unlock their secrets. Black holes are not empty spaces, but rather regions of incredibly dense matter. The core of a black hole is called a singularity, where density becomes infinite. Imagine the Earth squeezed into the size of a marble. That's the kind of density we're talking about. This unimaginable density creates a gravitational pull that is inescapable. This incredible density creates an intense gravitational pull. The closer you get to a black hole, the stronger the gravitational force becomes. Anything that gets too close to a black hole is trapped by its gravity and cannot escape. This includes stars, planets, and even light itself. The boundary beyond which nothing can return is called the event horizon. It marks the point where the gravitational pull becomes so strong that escape is impossible. It's like a point of no return. Once you cross the event horizon, there's no coming back, not even for light. Once you cross the event horizon, there's no coming back, not even for light. This is why black holes appear black. They emit no light that we can detect. That's why we can't see black holes directly. No light escapes to reach our telescopes. Instead, we observe their effects on nearby matter and light. You might wonder how these cosmic monsters come to be. Black holes are among the most mysterious and fascinating objects in the universe. The most common way a black hole forms is through the death of a massive star. These stars are many times larger than our Sun. Stars are gigantic balls of hot gas, powered by nuclear fusion in their cores. This fusion process is what makes stars shine so brightly. This fusion creates outward pressure that balances the inward pull of gravity. It's a delicate balance that keeps the star stable for millions or even billions of years. When a star much more massive than our Sun runs out of fuel, its core collapses under its own gravity. This is a dramatic and violent process. This collapse triggers a supernova, a powerful explosion that blasts away the star's outer layers. The energy released in a supernova can outshine an entire galaxy for a short time. If the core is massive enough, the gravitational collapse continues, squeezing the core into an infinitely small point called a singularity. This is where the black hole is born. This singularity is the heart of a black hole, a region of infinite density and gravity. Nothing, not even light, can escape its pull. The first black hole was discovered in 1971. This was a groundbreaking moment in the field of astronomy. It was located in the constellation Cygnus, a region of the sky that has fascinated astronomers for centuries. Scientists found it by observing a star that was orbiting an unseen object. The star's motion provided crucial clues. The object was so massive and had such a strong gravitational pull that it could only be a black hole. This discovery opened up new avenues for understanding the universe. Black holes come in different sizes, each with unique characteristics and mysteries. Stellar mass black holes formed from collapsed stars are the most common. These black holes are the remnants of massive stars that have ended their life cycles. These black holes are typically a few times more massive than our Sun, making them relatively small in the grand scheme of the universe. They are scattered throughout galaxies, including our own Milky Way, often hidden from direct observation. There are also intermediate mass black holes, which are hundreds to thousands of times more massive than our Sun. These black holes bridge the gap between stellar mass and supermassive black holes, These are thought to form from the merger of smaller black holes, a process that can take millions of years. Scientists are still learning about how these mid-sized black holes form and evolve. Their elusive nature makes them a challenging subject of study. At the centers of most galaxies, including our own, lurk supermassive black holes. These giants are the anchors of their galaxies. These behemoths are millions or even billions of times more massive than our Sun, exerting a powerful influence on their surroundings. They play a crucial role in the evolution of galaxies, influencing star formation and shaping the galactic structure. Their gravitational pull can affect the movement of stars and gas. Some scientists even theorize about the existence of miniature black holes, tiny but incredibly dense objects. These could be remnants from the early universe. These primordial black holes are thought to have formed in the early universe shortly after the Big Bang. They could be as small as an atom, but with the mass of a mountain. While their existence hasn't been confirmed, they could hold clues to the universe's earliest moments. Discovering them would revolutionize our understanding of the cosmos. The intense gravity of black holes creates some bizarre and fascinating effects. Imagine approaching a black hole. As you get closer, the gravitational pull on your feet would be much stronger than the pull on your head. This difference in gravity would stretch you out like a piece of spaghetti. This phenomenon is appropriately called spaghettification. Of course, no one would survive a close encounter with a black hole to tell the tale. The process of spaghettification would be fatal, stretching any object into a long, thin stream of matter. It's a testament to the extreme conditions that exist near these gravitational behemoths. Another mind-bending effect of black holes is time dilation. According to Einstein's theory of relativity, time is not absolute, but is relative to the observer's frame of reference. Gravity warps time, causing it to slow down in stronger gravitational fields. Near a black hole, where gravity is incredibly strong, time slows down significantly relative to an observer farther away. If you could watch a clock fall into a black hole, you would see the clock ticking slower and slower as it approached the event horizon. From the clock's perspective, time would be flowing normally. This mind-boggling concept of time dilation is one of the most intriguing predictions of general relativity. It has been experimentally verified, demonstrating the profound influence of gravity on the very fabric of space-time. Section 6. A glowing ring of doom. While black holes themselves are invisible, they often reveal their presence through the material that surrounds them. As gas and dust fall toward a black hole, they form a swirling disk called an accretion disk. The material in the accretion disk heats up due to friction, emitting intense radiation that we can detect. This radiation from the accretion disk can be incredibly bright, outshining entire galaxies in some cases. It's this glowing material spiraling toward the event horizon that astronomers often observe as indirect evidence of a black hole's presence. The event horizon itself emits no light or radiation. It's a boundary of no return, beyond which even light cannot escape the black hole's gravitational pull. Anything that crosses the event horizon is forever lost to the universe outside. Section 7. Could a black hole threaten Earth? Black holes have a reputation for being cosmic vacuum cleaners, but they don't roam the universe sucking up everything in sight. They are governed by the same laws of gravity as any other object in the universe. For a black hole to pose a threat to Earth, it would have to come extremely close to our solar system, which is highly unlikely. The vast distances between stars and the relatively small size of black holes make a close encounter extremely improbable. While a direct hit from a black hole would be catastrophic, the chances of such an event are infinitesimally small. We have much more to worry about from asteroids and comets than from rogue black holes. Section 8. Probing the darkness. Even though we can't see black holes directly, astronomers have developed ingenious methods to study them. They observe the effects of a black hole's gravity on nearby stars and gas. By studying the orbits of stars around a black hole, they can calculate the black hole's mass. Scientists also use telescopes to detect the radiation emitted by the superheated material in accretion disks around black holes. These observations provide valuable insights into the feeding habits and properties of these cosmic behemoths. In recent years, the Event Horizon telescope, a global network of telescopes, has captured the first ever images of the shadow of a supermassive black hole. These groundbreaking observations have provided unprecedented views of these enigmatic objects, confirming their existence beyond any doubt. Section 9. Conclusion: Mysteries yet to unfold. Black holes remain some of the most mysterious and awe-inspiring objects in the universe. They challenge our understanding of gravity, time, and the very nature of reality.